The sacrum. The sacrum, I said, was 5 fused bodies. I've numbered here the S1 through the S5 bodies. The key here is the ala or ala. The word means wing. These are the transverse processes all fused together to make this portion of the bone. We have these transverse ridges between the bones. Those are the epiphyseal plates between the bodies that would have been hyaline cartilage for the epiphyseal plate. If they were free moving, this is where the vertebral disc would have been, but it isn't. So this is how the bone grows. And very importantly, we have these ventral sacral foramina, or ventral sacral ventral. Order sacral and ventral don't matter as long as you get both concept. It is the sacrum and this is ventral. This is one of the few places that we actually have to use the word ventral. The plural of foramen is foramina. For the ventral rami nerves, rami is the plural of ramus. Posterior, superiorly, sorry, we're going to start with superior. We have the sacral canal. This is the continuation of the vertebral foramen. This is for the end of the spinal nerves and the end of the spinal cord. It goes all the way through the posterior of the bone to end at the sacral hiatus. Looking at the posterior of this bone, we see that we have dorsal sacral foramen. These are for the dorsal rami nerves. We have the articular surface for the ilium, which will make the sacroiliac joint, which is a planar synovial joint. That's how we attach the os coxa to the sacrum. And we have these ridges going down the center of the posterior sacrum. That is median, not medial, median with an N, sacral crest. That is the fused spinous processes. And the sacrum ends finally at the sacral hiatus, which is the opening at the end of the sacral canal. This is where the last of the spinal nerves emerge. The coccyx. The coccyx is that variable region where it has 3 or 5. What you would have to be able to do for the coccyx is simply, remember it's not random, and that if I put this model out, I would simply say, what is the name of this group of bones? And you would just have to identify it as the coccyx, or if it was on a skeleton or another model, but it was its only identification. Here's another picture of the coccyx on a model. I liked this picture because it gave a better view of the sacral hiatus as well as the coccyx attached. And these are the median sacral crest again as they come down and fuse. Ribs. For the ribs, this is the first bone you will have to be able to tell right versus left. The key to this is the landmarks of the rib. We have the head of the rib that goes to the vertebra. We have this angle of the rib that is the curvature, and the sternal end of the rib is what attaches to the sternum. Now, if we rotate it so that we can see on the medial edge, the deep edge of this bone, we have this subcostal groove, and I had you all feel that with your fingers so that you could actually feel that subcostal groove. That goes inferiorly. It's on the deep edge. So in order to tell right from left, you have to find the head, which goes posterior, the angle, which goes laterally, and the subcostal groove, which will go inferior. Now, the other landmark on the rib that you have to be able to find is this bump. It's called a tubercle. The word tubercle just means bump. Here's a sternum. This is the real sternum we have. The sternum is made of 3 individual bones that then fuse: the manubrium, the corpus, which is also called the body, and the xiphoid process, which is mostly broken here. The xiphoid process is the last piece to calcify, so it sometimes doesn't last very well and it can easily break. The sternal angle, which is where those 2 little red arrows are, is the junction of the manubrium and the body. The sternum has 2 landmarks that you have to be able to identify. The top one is the jugular notch, which is right at the top. That is, the jugular veins are just inferior, or not inferior, but deep to it. And the clavicular notch on each side, there's 2 clavicular notches. That is for the sternoclavicular joint. The sternoclavicular joint is sometimes classified as a planar joint. It is the only axial to appendicular joint for the upper limb. This is how we attach the upper limb of the clavicle to the axial bones of the sternum. If I have a sternum in plastic, what you should notice is that the ribs are represented by the costal cartilage, which is plastic here. And the key here is that rib 7 does come up and attach to the sternum, which means that ribs 1 through 7 are what we call the true ribs. There's 12 pair total. 1 through 7 are the true ribs. Ribs 8, 9, and 10, you can see, actually fuse in to the cartilage of rib 7. So they are called false ribs. Ribs 11 and 12 are not here because they don't have cartilage. They are the floating ribs. So ribs 11 and 12 are the floating ribs. The hyoid bone is a small horseshoe-shaped bone. It's in the neck cervical region. It is just superior to the larynx, which is made of hyaline cartilage, and it's anterior to the cervical vertebra. It does not actually attach to the vertebra. Instead, it hangs by these long ligaments, which makes it unique, and that it is the only bone that does not actually form a bone-to-bone connection. The hyoid bone is important to swallowing. Every time you swallow, it moves, and so that the epiglottis covers your larynx so that food goes down the esophagus and stays out of your larynx and your lungs. It also keeps your airways open. Forensically, a broken hyoid is an indication of strangulation, so they have to watch that. But it keeps your airways open, and we like the airways staying open. This photograph of the hyoid is showing that it's actually on wires in the skeleton. The skeleton is the one in the lab, and you can see its individual bone there.